Now what's the hard part? The hard part is that merge sort is a recursive algorithm. So it keeps spawning off new versions of itself, okay? And so not only does the outermost two recursive calls, but then those two recursive calls spawn two more each, and each of those four spawn operation of sub is doing some work, in particular each of which has to do a merge at some point. So that's a little frightening. What we have for us is that, well, at least when we recurse, we do it on smaller problem sizes. In fact, substantially smaller problem sizes, only half as much as what we started with. So the battle between the forces of evil, these proliferating subproblems, forces of good, the input sizes, how it plays out. Okay, and at the end of the day, when all the calls have popped off, what do we really do? And if you do go about that the wrong way, it's pretty intimidating. The right way is to organize the work in a particular way so that it's very easy to execute. And so that's what I'm going to show you now. Organize the work performed by a recursive algorithm like merge sort so that it's relatively doable to figure out how much work it does overall. In the back.
How negligible is the difference between different types of operations?
Good question. Let me defer that for about 10 minutes. Yeah. So for the purposes of this class, negligible. That's the short answer. Okay. So here's what we're going to prove. So claim merge sort requires at most 6n times log base 2 of n plus 6n operations to sort n numbers for every value of n. Okay. So that's what we're going to prove next. All right. Now, in my experience, some computer scientists have sort of irrational fear of the logarithm, which I've never understood. But if you're in that category, let me just briefly demystify the logarithm for you. What is base 2 of n? We'll type n. So recall log base 2 of n, number of times you divide by 2 until you get to 1. And if you play around with your calculator a little bit, and probably you all know this anyways, but the upshot is, you know, while the log will go to infinity as n goes to infinity really quite slowly, pleasingly slowly. Okay? So if you drew the linear function, the identity function like this on the x and y axis, function would be seeming to almost level off. It doesn't level off, it keeps getting higher and higher, but you have to go more and more to the right. Okay, way more to the right to get it to keep going higher. Okay? So in particular, when we say that merge sort has time, you know, roughly n log n, that's a really substantial over the obvious sorting algorithms like selection sort and insertion sort. Okay, because those are roughly n squared, so we've replaced a factor of n something much smaller, this log function. And after we finish proving this claim, I'll discuss more about these comparisons between different functions. Okay, but let me prove this first.